Wagwan everybody, it's your boy Mr. H again. Today we have a question for particle physics, which is also my favorite branch of physics because I love space, I love particle physics. I know they're not exactly the same, but for me, I loved both of them when I was studying in school. Although I didn't become a particle physicist, but here are some questions about particle physics. So the question here asks: a crystal structure can be investigated using the diffraction of an electron beam. A typical diffraction pattern is shown to us. So now, the question asks, in a particular investigation, the atomic spacing of the crystal is given to us, and the electrons are accelerated through 3000 volts. Calculate the wavelength of these electrons. Okay, so now we need to find the wavelength. And so you can work backwards, or if you already know, you can just go right ahead. But the first thing is, which I'm going to use two equations for kinetic energy. One I'm going to say is going to be equal to EV, which is going to be the charge of an electron multiplied by the voltage applied across. And charge, of course, is known to be 1.6 into 10 to the power 19 coulombs. And the other equation for kinetic energy I'm going to use is going to be equal to half mv squared, which is most of us know. Okay, now because both kinetic energies are going to be belong to the same electron, I can equate the two, and I'm going to be isolating for speed. The reason I am isolating for speed is because I know that wavelength is connected to speed using de Broglie's wavelength equation, or de Broglie's formula. So what I'm going to do here is I'm going to say EV is equal to half mv square, and then I'm going to isolate for speed here, or velocity here in this case. So I can say v squared is equal to 2ev divided by m, take the square root on both sides. And so I know my velocity will be equal to square root of 2ev divided by m. So all you do is just plug in everything you have. So we become 2 multiplied by the charge of an electron, which is 1.6 into 10 to the power 19 coulombs, multiplied by the voltage which we supplied, which is 3000 volts, whole divided by the mass of a single electron, which is 9.11 into 10 to the power negative 31. Now, don't worry, your teacher or professor will most likely will give you these values, and all you'll have to do is just know how to process and how to go from one step to the next. So I know my speed now is going to be 3.2 into 10 to the power 7 meters per second. Okay, so now after all of this has been done, now like I said, I'm going to be using de Broglie's formula for wavelength, and that is wavelength is equal to Planck's constant divided by mass times velocity, or speed here. So Planck's constant is going to be 6.63 into 10 to the power negative 34 joules second, divided by the mass, which is 9.11 into 10 to the power negative 31 kilograms. And put this in a bracket actually, so it's not confusing, and multiply by the speed, which we just found, which is going to be 3.2 into 10 to the power 7 meters per second. Okay, so once again, just put it on into a calculator, and then it will spit out 2.24 into 10 to the power negative 11 meters as my wavelength. Okay, so this is the wavelength at which these electrons were in our investigation, which we used. Now, just a quick recap is that I used two kinetic energy formulas, one for the electron. Let me highlight all this in blue, actually. So one for the kinetic energy for an electron using coulombs and voltage, and the other using mass and velocity, because I need to find velocity. The reason I need to find velocity is so that I can put it into de Broglie's formula for wavelength, which uses Planck's constant. Okay, like I said, there are a couple other ways to do this, but this is the method which I feel like is the best approach to this. Once again, as long as physics and math are very vast branches, and if there are multiple ways to get to an answer and they're all correct, that's fine by me, and that's fine by pretty much every academic person there should be there. So all in all, I hope you guys understood. If you guys have any other questions, please leave them down below, and I'll see you on the next one. Peace.